I'm going to talk about polar coordinates. I will assume that you are familiar with rectangular coordinates, including plotting functions on XY coordinate planes. All right? If any of that is unfamiliar to you, I would invite you to watch the necessary videos. So now give me a moment to draw a picture. Okay, so I've drawn a picture of an XY coordinate plane with a circle of radius 5 centered at the origin. And I've also identified a point on that circle with a green dot. And I've identified a right triangle that has that green point and the origin as two of its vertices. So suppose we wanted to specify the position of that green point. So in rectangular coordinates, it should be clear to you how that is done. We would specify effectively the legs of the green right triangle that I drew, so 3, 4. So that's how we specify that position with rectangular coordinates. Now, can you see that by specifying the radius of that circle and the angle of that triangle, can you see that with those two different bits of information you can still identify the same position? All right, so there are different ways to specify positions in XY coordinate planes. You can specify essentially the legs of a right triangle, or you could specify the length of the hypotenuse and an angle of a right triangle. If you specify the hypotenuse length and the angle, that is referred to as polar coordinates. Okay? And you can specify the two bits of information with respect to polar coordinates in the same compact form as you do for rectangular coordinates. So instead of 3, 4 inside of parentheses, I could have 5, 53 degrees inside of parentheses. Okay? One is a position specified in rectangular coordinates, the 3, 4. The other one is a position specified in polar coordinates, 5, 53 degrees. Now, you need to know the the type of coordinate system that coordinates refer to, of course. But once you do, it should be clear how to identify the corresponding position. Now, why do we use polar coordinates? Well, sometimes polar coordinates are more convenient than rectangular coordinates. So it's good to know both options. Okay? So let's identify some positions using polar coordinates now. Let's do some examples. So give me a minute to make a sketch of an XY coordinate plane. All right, so suppose we wanted to identify the location in polar coordinates of the point with the coordinates 2, pi over 4. So we know that the position is going to be a distance of 2 from the origin, and that position is going to be in the direction specified by an angle with a measure of pi over 4 radians. So that's going to be roughly where this blue dot is. Okay? Now, what if we wanted to specify the position denoted by 2, minus pi over 4? Well, that point is still the same distance from the origin as the previous point. However, the direction is the direction that corresponds to an angle with a measure of minus pi over 4 radians. So that would be roughly where that second blue dot is. Okay? And what about if we wanted to locate the position with respect to the coordinates minus 2, pi over 4? So let's think about that one. So we know what direction pi over 4 radians corresponds to. Now, because the first coordinate is negative, what that tells us to do is move backwards. Okay, so move in the opposite direction that corresponds to pi over 4. So if we move the distance 2 in the opposite direction, we would end up approximately where this third blue dot is. Let's put it about right there. Okay? And then let's do one more example. What about the position with respect to the polar coordinates minus 2, minus pi over 4? So we've established the direction we have to move with respect to minus pi over 4 radians. And once again, we have to move in the opposite direction. So those coordinates correspond to the point approximately where this fourth blue dot is. All right? So I hope that was clear. Now I would like you to try to identify some positions associated with specific polar coordinates. So give me a minute to make a picture, and then I'll ask you to try some. All right, so on my coordinate plane, can you identify approximately where the position is associated with the polar coordinates 3, 5 pi over 6, as well as minus 3, 5 pi over 6? So pause the video and try to do that now, please. Okay, so I'll go ahead and do it as well. So 5 pi over 6 is an angle that's greater than a right angle, but less than a straight angle. It's equivalent to 150 degrees. So we've got the direction established, and then we have to move a distance 3 from the origin, so that will get us approximately where that red dot is. Okay? And for the second position, we will move in the opposite direction from the origin, and that will get us approximately where this second red dot is. Okay? Let's try one more example. Give me a minute to make a quick sketch again. All right, so would you please locate the approximate position of the following points in polar coordinates? 3, pi, 3, minus pi, minus 3, pi, and minus 3, minus pi. So pause the video and try to do that now, please, if you like. Okay, so I'll go ahead and work these out as well. So the first two positions are with respect to the same direction. That's because pi radians and minus pi radians both correspond to the same direction. And I'm going to move a distance 3 from the origin. So both of those positions are going to be the position associated with that red dot. And the third and fourth points are going to be where I'm going to end up if I move in the opposite direction the same distance. So the third and fourth points both correspond to the position approximately where I've just placed this second red dot. Okay? Now I would like to shift gears and talk about polar plots of functions. So the same way that we can plot functions with respect to rectangular coordinates, we can plot functions with respect to polar coordinates. The same way that we can associate y values with x values, we can associate r values with theta values. Okay? So let's think about some examples. Suppose that we had the equation r is equal to 3. So what that means is that for all angles, for all directions, we have to move the same distance from the origin. Okay? The distance of 3. So what is the set of points that is a distance 3 from the origin. So clearly that would be a circle of radius 3 centered at the origin, right? So let me draw what that looks like. All right, so there is the polar plot of that polar equation, r equal to 3. Okay, now let's do another example. Suppose I wanted to plot the polar equation theta is equal to pi over 4. So what that means is that for every distance from the origin, we're going to move in the same direction. We're going to move in the pi over 4 direction. So the set of points that corresponds to that equation, can you see that it would be the line denoted by this green line? Okay. So those are two examples of polar plots, and you can have polar functions, okay, that correspond to polar plots. Now let's do a little bit more involved example. What if we wanted to plot r equals theta over pi? So what I would recommend when it's not obvious what a plot should be is that you make a table with some sample points. So let's put some theta values in one column and some r values in another column. So let's see, when let's do 0, let's do pi over 4, pi over 2, pi, 3 pi over 2, 2 pi, let's see, 5 pi over 2, and 3 pi. And we'll stop there. All right? So for all those theta values, we have to divide them by pi to find the corresponding r value. Okay, so now let me draw a sketch of the plot. So give me a minute to draw an xy coordinate plane. Okay, almost done. All right, so for the first row, 0, 0, we'll have a point located at the origin. For pi over 4, 1/4, we will have a point located approximately right there. Pi over 2, 1/2, approximately right there. Pi 1, right there. 3 pi over 2, 3 over 2, right there. 2 pi 2, right there. 5 pi over 2, 5 over 2. 3 pi 3. So putting it all together, if you continue to locate more and more points, then I hope eventually you would see that the plot is a spiral. that looks something like that, and it would continue spiraling if I kept adding more and more points. Now, why is it a spiral? Well, think about what the equation means. It means that as the direction, as theta increases, the distance from the origin increases, right? So, can you see that in a spiral as you move around along the curve of the spiral, you're getting farther and farther away from the origin, but you're also constantly increasing theta. All right, so now I would like you to try to do an example. Would you please try to find the polar plot that corresponds to the polar equation r equals 4 cosine of theta? So pause the video if you like and try to work that out now, please. All right, so I will tell you the answer you should have gotten, and if it's not clear how or why this is the correct plot, remember that you can always generate a table with as many points as is necessary to see the correct plot. Okay, so the correct answer is a circle of radius 2 with its center at the point 2, 0. So the plot will go through all of those 4 points associated with those red dots. And so it'll look something like that. Okay? Now, let me do one more example. By the way, you can also confirm various polar plots by using software, and I would highly recommend you find a program that can do polar plots and explore. Try to make up some polar functions and see what the plots look like. The students often end up fascinated by the plots that turn up. Okay, so r equals the cosine of 3 theta. So pause the video if you like and try to work out that polar plot. Okay, so I'll go ahead and show you the answer you should have gotten. So the plot contains the origin, goes through the point 1, 0. It has a point out here, has a point approximately right there. So what you should have seen is something that looks like a flower with 3 petals. something like that.